Hello everyone, welcome back to my channel Clinical R Insights. So in this video, we are going to learn custom and user-defined function in R step by step. So in this video, I will explain what function is, how to write it, and different possibilities like function with arguments, without arguments, default arguments, and even I will explain one clinical example as well. So this video is very useful for those who are coming from a SAS background or those who are beginner in R. So let's start. Next is, what is a custom function? So in simple words, a function is a reusable block of code. So instead of writing the same logic again and again, we write it once inside a function and reuse it multiple times. Similar to the SAS macros. We create macros and we use macros again and again for different purpose. In R, we create functions. So we create our own function using function keyword. I will explain how we create our own customized function. So basically, we provide input, function process our input and our give output to us. So this is a workflow for functions, customized function. Next step. Why do we need functions in R? To avoid repetitive codes. So we can reuse that function and again and again without writing repetitive codes. Improve readability. We can easily write our code in a clean manner. So easy debugging, because if we are not writing code again and again, so we can easily debug our program. Used heavily in clinical programming. It's very useful. Without function, like just like without macros, we can't survive in clinical domain. Similar in R. Without function, it's very difficult to write codes in R in clinical domain. So we will see each and every example step by step. So let's jump to Star R Studio so that we can see uh, these with example. So this is my R Studio screen. Hope you can see my screen. I cleared my global environment with rm command. You can see this, and my console is also clean. So we can start writing the code. First example I want to show you function without argument. How how we create function. Let's start with a very simple example. We are not passing any argument. We are just writing simple function with one message. Say hello. This is my function name that I am creating. So this is my function name that I am creating. I am using function keyword. This is my function keyword. This is from base R. So and how we write, which I have to first enter, and yeah, this is the syntax you can say for function. We pass our arguments in this, and our all the calculation or all the thing that we want to do, we have to pass in these two curly braces, right? Now I'm not passing any argument. I'm showing I'm without argument. I'm not passing any argument in this bracket in parentheses, right? Now like in curly braces, I'm writing just a simple text like, let's say hello, welcome. So welcome to clinical R Insights. This is my channel name. I'm writing. So yeah, I'm just writing a simple text. I'm not passing any argument, and I created one function just from this. So yeah, my function is created. You can see this in global environment that say hello is a function without any argument. I'm not passing any argument. Okay, just now how we call a function. Say as we call macros. It's completely similar. this is like we are you can say that we created one macro. Now we are calling that macro. Definitely, way of creating these two are completely different, but they are doing the same work. Okay. Hello. This is from the global environment. Yeah, that's it. No argument we passed in the function and no argument we are passing in calling. Just call the function. Look, it will give you the simple text. Hello, welcome to Clinical R Insight. That's it. This is very simple function. Uh, Basically, whatever I am providing, it is giving me back. So these functions are useful for like message, logs, or a default output. If you want to provide any message, you can write these kind of function. It's very simple. So, so whatever is written inside the curly braces is executing and are automatically return the last line. Whatever. Let's say I write two lines here. Let's say I write hello. Just okay. These two. Okay. Now just run and call the function. But it will give you the only the last line that you provide to your that you provide in curly braces. Let's say instead of this control C, I'm just giving third line. Yes, I'm writing this. Now run. Okay, now run the this is the last text that we provided inside this curly braces. This function will return that only. So we can use this for messages, log, and default output. So this is the first way we create our function for providing the message without providing any argument to the function. So next, function with one argument. Now we are giving one argument in this parenthesis, okay? So let's create one more function, sq underscore num. I'm creating my function with this name and I'm using function keyword run and x. I'm providing one argument. Just like in macro, we provide one macro parameters, right? We provide. So now uh, curly braces, and in that I'm saying I want square root. Just run this function and sq calling. I'm calling just like in SAS we call macro. Okay. In that I have to provide the value of x. What is x? We have to provide x any number. You can positional. This is a positional. We are not providing this. We can directly provide like 5. Okay. Just run. This is 25. Okay. It is calculating 25. So I can change any number, let's say 7 and run. Now it's changing. So it's basically we are providing one argument, only one argument, and we are giving the value of that argument while calling that function. So this is the way we can create a function with only one argument. Let's come to the multiple argument. Let's say we have 2 or 3 arguments as we provide in our macros in SAS. So let's say add underscore num. We are creating one function for addition function and I'm providing 2 arguments A and B. These are the 2 positional arguments. Okay. Now I'm saying okay I want 1 plus A plus B 1 and just run this. We have to run this function. Okay, this function is correct, no error. Now add, I'm calling num and I'm providing 2 numbers here because I provide 2 arguments in my function. So I'm just giving the 2 plus 1. Okay, 30. It's giving me the answer with 2 arguments. Multiple argument. You can give, okay, you can give one more. And in that, you can use this and just run. Okay. I need to run the function as well. First, I need to run the function because I need to update. It was giving me error because I provided three numbers, but previously it was only two arguments were there. So again, I have to run the function, then it will take that argument. If there is only two argument in your function and you are giving the three numbers or more numbers, then it will show you the error that one argument 34 is unused because only two argument that function can accept. So this will give you error. So by this you can create multiple argument in your function. So by this you can multiple argument. But let's say I provide two things here. Let's say I'm saying I want a scare as well as the cube. So I'm running this and running this. It is giving me only this one, not the this one. But let's say you want the both. You want first calculation as well as the second calculation in your output. How you can do? Because function always give you only one output as a uh, uh, result. But if you want two, both, how you can do? By look, I'm just copying and one way. I'm saying say first how we can do by creating a list inside a function. How we can create just add list. List is a very versatile. I already explained in my video when I explained the data type. If you want, you can watch that video because list is very versatile and flexible. So let's say I'm creating, okay, scale. This is scale. I'm creating the name for this and this is cube. CU I'm creating, okay. So these two these two output I want in my output. Now just run this function because I added the list function inside. Oops, there is a missing ticket. Yeah. Now just run. Okay. Now run this. Now you are getting both in a list format, right? In a list format, you are getting both. Let's say you want this output in a vector form, not in a list format. How you can do it? Now the second way, how we can get the both the calculation or output in our output. Okay. Now I'm copying. I'm just keeping it here as a C. Okay. Now done and run this. Look, I'm getting in a vector format that these two output scale 49 and this and this is a list format. In by any way you can get according to your requirement. You want the output in a list form or a vector form. So these are the two way if you want to get both the output. So you can easily do that by creating a list or with vector because function always gives you one object only as a output, but by this way you can get both the output similar for all the. So this is the example with one argument and this is with multiple argument, and these two method you can use for all the output in any case. Even in the multiple argument you can easily use that. Okay. So by this, these are the two way, and the next is function with return statement. With example, we will understand this return function in functions. Okay, let's create one function, calculate sum, and creating one function. I mean passing two arguments, y, x and y. Okay, and just do result. Result is equal to, or you can say assigning x plus y. Okay, and let's first run this and see. Okay, this is the, and this I'm just passing two arguments. Oops. Okay, let's copy and paste and just pass to any two arguments. Let's say 45 plus, sorry, 45 and 15. These two argument I'm passing and I'm getting, look, it is not showing any result because we assigned these calculation in this uh, object, right? We created one object inside the function. Let's say first remove this and see how it show. And now run. It is showing the result 60. But when we assign this output to a object, it will not show you the result. For that, if you want to see the result, what you have to do, you have to pass res result function, and in that you have to pass this argument and then run. Hmm, see, it is showing error because we have to write return. We write result in both the, yeah, now it will run, just run. Okay, now we are getting the output because we ask R that return this value as a result. Previously, it was not showing out output to us, but now with this return function inside the function, when we use, it will give us result. And let's say we want to use this result in our code, like in future code. So how we can do? We have to pass. Let's say I'm creating one x. Let's say x variable, and then no. Let's go for something else. Let's say sum. I'm creating or sum underscore one. I'm using. Okay. Now just when you print this, it will show you so that now you can use this object anywhere, wherever you want to use this calculation in your report creation. Let's say you did some, you create one function for us in your report, for your report, and you want to use that function somewhere else. So you can assign this calling part of a function in a object, and now you can use this object. So whatever you pass in a return statement, it will give you that result. Let's say I have one more, let's say sub I'm creating, okay, underscore one, okay, and I'm passing x minus y, but I ask R that I want only this output in my result. So now run. First run the function. Okay, now run. And it is showing still 60 because we in return function we pass only the result as a output. Let's say I want to change this to sub underscore one. Now run this function. Whatever you pass in a return, it will return that value. The basic concept is this. Now run this and print this, showing 30 because now we change the value in return statement. So by this we can change it. And let's say you want the both. You want both in your output. So for that you have to use list as we did previously. Like you have to pass sub one, and that is second one is result, right? Just one. I need one more parenthesis here and then this code, and now this is list. If you want to give the name to this list instead of one and two, you can give. Let's say I want to give this sub. capital sub. I want to give the name to this. Just run this and look. I change the name. And you can do one more thing. You can, instead of creating the list, you can create the vector. Uh, so this is vector. So basically, you can use this object anywhere for future calculation or future output. You can use this, and this is our function. Whenever you call this, it will automatically call this function and pass these two arguments to your functions. So this is very versatile. And one more thing I want to show you. It's a local. If you, let's say, if it's a local creation, like just like similar to the macros. In macros we create local macros and the global macros. It is creating a local object inside the function. Let's say I have one more subject, like I have RESULT result as a object outside this function, and it has a value of let's say 3. This is my, I want to show you this. So this is showing, okay, result, you have value of 3. Now I'm running this. Okay. Or instead of, for global creation, you have to use this 2 greater mark and 1 this hyphen. Then you can create this as a global result. Let's run this function and call this function. Now check the value of result again. Now it's changed to 60 because inside this function x plus y is equal to 60. So it change automatically the any similar name object present globally. Result is present outside the function, right? Its value is 3. But when we created one global object inside the function with this two greater bracket, greater then symbol and then hyphen, then it will change the value of object that already present in a global environment. So basically, it's a creation of a global object inside the function. This is the way we can create, but it's not a better way to create like object inside the function, because you might change the value of similar object outside the function. So it's better to avoid this. Just use a similar or equal to. So these two you can use. So it will act as a local creation, not the global one. So now run this function and this, and just run the value of result. Still showing. Let's change. First we have to run this. Okay. Now we are creating function and oops, we are calling the function and checking the value of result. Now it's showing 3 because we have created the local object inside the function, not the global one. So by this way, you can create the global and the local object inside the function, similar to the SAS global macro and the local macro. So this is very important concept in our function with return statement. So whatever you pass in a return, it will give you that value. Let's say I'm not giving the value of, mm, let's say result I'm not giving. So just remove this combine operator as well. Okay, now run and run this as well. So when you call this, you basically you are getting the 30. So yeah, it's a bit confusing, this return statement, but when you practice once or twice, you can easily understand that how this return statement is working, and how you can extract the object from a function for the further analysis. So this was the concept of a return. Now without return, we already did, but let me explain once more. So just copy this and paste here. Okay, now we are not using any return statement. Okay, and we are just running this. Okay, first I'm just removing this and I'm just calling this function. It will not give you, first thing, it will not give you any output if you are not using the return statement. It's explicitly telling R that yes, I want this output. But let's say I'm sum underscore 2. I'm using this for my, uh, I am creating one more object and passing this value to this object. I'm just run. Now run this sum underscore 2. Okay, this is giving me 30 because this was my last argument that I provided, last statement that I provided in my function. So it is giving me only that result. But let's say I want the result in my output, or I want the both. I have to use this return statement. So basically, this is the example for the without return statement. Whatever equation you passed in your function last, that will resolve only. But if you want your all the statement to be resolved, or you want in your output, then you have to pass the return and you have to say, okay, these are the object I want in my output. You have to explicitly tell R, I want these all the object in my output, whether in a vector form or a list form. It's your choice because by default function will only give you only one object as an output. Okay, so this is the basic concept of return and without return. Let's come to the function with a default argument. It's similar to the SAS macros in which we pass the value of a parameter. Let's say we are passing, we are creating a macro definition, okay, and we are defining a positional, sorry, keyword macro variables. Okay, keyword macro variables. In that we already passed the value of that macro variable. So it's a completely similar concept in R with default arguments. So how we can do it? For that, I am creating one function. Let's say for the calculation of uh, BMI, I'm using clinical example. Let's say I'm calculating BMI. This function we usually use in our um, table creation, like whenever we have height and weight, we calculate BMI. So we can use this function. So I'm just creating this function, let's say function, and in that I'm passing weight as a positional argument and height as a keyword 1.7 value. I'm already passing by default. I'm passing this, and in that I'm creating, okay, BMI and formula for BMI calculation, weight, let's copy and paste, divided by height and square root of 2. So this is the formula for the BMI calculation. I'm sorry, I need to give it again, break it down. And I'm printing BMI. Now run. So by default, we have only one calculation. It will give us result. So I'm just calling my function. Oops, I did the name. That's okay. It's just a name of a function. So I'm just calling. And here I provided the height by default 1.7. Now I have to give the value for the weight. Let's say weight is 70. Now run the function. Now it's giving us the value for BMI calculation. But let's say we want to change the height. We can easily do that with this function. And I'm passing, let's say height is 70, but I want to change, sorry, weight is 70, but I want to change the height. Let's say this is the height I want to change. Okay. we already pass, that is default, but we can easily change that. Okay, now it will give us a different output because we changed the, it's similar to the SAS macro, right? If there is a default, we can also still change that while passing the values, while calling the macros, or while calling the function, we can change the value whether it is defined or not. So it's very straightforward that we are changing the default argument that we provided while calling the functions. So done. So this is the function with a default argument. We can easily change that. So next is function with a conditional logic. So we can also provide the logics as well while creating the function. How we can do? Let's say we want to create a category for BMI. BMI underscore cat function I'm creating. I'm using function as a keyword. I'm passing the BMI as a argument. Only single argument I'm passing. And now it's a we want a curly braces. So in curly braces, I'm saying if BMI is less than 18.5. So it's a if else statement. If you want to learn how to do if or conditional processing of your data, I can create one video. If you really want to learn, please comment below. I will create one video on all the conditional statements and loops as well. If you want to learn, please comment below. I will create one video for this. For now, I'm just creating this conditional logic inside the function to show you how this works. Under, I'm saying if the BMI is less than 18.5, that person is underweight. Okay, done. Else, this is the way we write uh, if else statement in R. Else, if, else if, sorry, this is we have to provide a condition. Else if, but BMI is less than 25, then we want that person BMI is normal. Let's go for the caps. Done. Okay. Now next is this to create. It's very confusing sometimes where to start the like brackets and all. Yeah, it's little confusing. If you are a SAS background, we don't use any kind of these kind of curly braces and all in SAS. Definitely in R, it's a bit confusing if you are a beginner, but slowly you will understand like how this work. SAS. Now curly braces again. Now we are saying this person is over overweight. Back. Now run this complete function. Okay, now call this function BMI underscore cat. This was our function, and I'm passing. Oops, it should be in same. If you created the function in a capital, then you have to pass capital letters, and otherwise in lowercase. I'm passing 23 as a BMI. Just run this. So that person is in normal range. If that person has 23 as a BMI, that person is in lies in a normal range. So by this we can create conditional logics inside the function, and with this we can resolve that function by passing the argument value. So this is an example for a function with a conditional logic. So next is a function with a vector input. Here we are giving only the one value, right? In previous example, we pass only the single value for our argument or a function. If we have a vector input, how we can do that in functions? Understand this? We have to create one variable like function. I'm creating flag, like flag as flag function for let's say age. Okay, this is my function I'm creating, and I'm passing age vector because we are in this example we are passing as a vector input. So I'm just for understanding I'm just giving the name as a age vec. This is a argument I will pass when I will call the function. Now I'm passing if else. This is from this if else is also from the base R, but we have one more if else that is completely similar to the base R from deployer package. In that we use underscore. This is only different from base R if else and replier if else. But I think speed wise, replier if else is better than base R. I don't know exactly, but yeah, definitely this is a difference. Okay, I'm passing age vector. This is the vector I want to see for my flag. Okay, this I'm saying okay, age if any person's age is greater than 65, just say yes, and else say no. So they are the two way we write if else statement. One is this simple, and one is this if else if. This has its own use case. This if else has its own use case. So both are important. So you have to choose according to your requirement. So just run this, but just run this function and let's call this function, and here I have to pass the vector input. So combined operator, I'm passing age, so it's a numeric vector, so 70 and let's say 66. Okay, just call. Okay, we ask R in this function that if age vector is greater than or equal to 65, say yes, otherwise say no. So in these two cases, this condition is true, right? So it's showing yes. Else no. For this one, it's showing no. So by this way, we can pass our vector input to our function. So it's very important. In clinical domain, we use this kind of function. So it's important. Function with vector input. Now function using dot 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 variable argument. How we use dot 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 in our function argument. To understand this, we have to create one function. In that I'm calculating mean. In that function I'm using function. It's simple dot dot dot. In R it's called as ellipsis something like that. So what does these dot dot means? So this allow a function to accept any number of arguments. You don't need to define how many input uh, we are passing. Any number of input you can pass if you are giving this in a argument, uh, uh, then you can pass any number of input. How? Let's see. V, but you have to use this three dots in somewhere inside the function, then only you can pass that value or you can use that value. Let's see, I'm creating one vector and with dot dot dot. Okay, and now this vector I'm using for calculation of mean. Let's give this value. Okay, value for mean calculation I'm using value. Okay, mean, and in that I'm using values. This vector that I created, I'm using this. Just run this. And for calling, give any number of values. No need of using combined operator here. 30, 67, 89, 45. Any number of value you can give. Just call this. Look, it is calculating the value. So let's say this is kind of a versatile function creation. Like let's say you initially you have only four values in your variable, let's say in a object, but later you found like two values again increased. You can add easily. No need of changing the argument. Let's say a plus b, a b c d e f. Any no need of changing that argument. Just pass this three dot and you can change your values while calling the function. So this is very important. But if, if you are using three dot here, then you have to use somewhere inside the function. Then only you can utilize that. Similar to the argument. So basically, instead of passing the argument, you are passing the dots. That is versatile. You can pass any number of input for your calculations. Basically, this is it. Initially we have let's say four, but later we found three more person added to our research. So we just adding the data to this and it will calculate the mean automatically or any other function you want to create. So it's very good. So we can do any calculation with this function. And no need of adding the combined operator here. We already passed in our values that we want to combine all these values, so it will work. Next is function with a NA handling. Very important for clinical domain because NA value is very crucial for our calculation for any report creation or anything. So NA handling is very important in our domain. Otherwise, it will give you false result. So for that, what we can do, let's say for mean calculation, NA values is very important. How to handle that in by creating the function. So let's create a function called mean, okay, and function in that I'm just passing x as an argument and I'm creating mean, and in that I'm saying na dot rm is equal to q. So now run and call this function. We want to pass the vector because some values like I think it's in caps lock. Let's say 10, 20, NA, and 30, right? Just run this. It will give you mean calculation. Let's say we remove this, will give you NA because mean for mean calculation we have to handle that NA missing value, then only it will show you the uh, correct output, right? So one way is we are passing this like vector we are passing and vector we are using. Let's say if we want to do this function in this way, you can easily do that by passing the three dot and similar values combined operator and mean calculation with in which you are passing the NAs. NA dot rm is equal to true, so you can use this as well for this calculation and a handling. You can use this if you don't want to pass just a vector. If you want to just pass a simple numbers, so you can use that with this values is equal to combine operator and three dots, and then you can use this. So next example is like clinical function missing value check. Let's say we want to check any missing value in a vector. How we can check? I'm creating one function check underscore miss, and in that I'm passing values as a input and in curly braces Oops, I think I did wrong. Just delete this. Create again is buckets, and in that I'm saying if else. I'm creating one function is dot na, and then passing the values, this argument here. If there is any NAs in this value that I will provide, give missing, else give not missing. Done. Now run this function and pass the value. Function, and I'm giving C as a vector input I want to give. So NA 64, let's say again NA 90 and 56. Okay, let's just check. So it is showing. Okay, NA missing and missing. Two observation we have missing. That's why it is showing missing. So by this you can do some QC checks. So for missing values, which is very important for analysis. So by this you can give just a variable or a vector to this. You can give variable as well from a data frame. How you can give, just let's say you are doing a ADSL and you are working on a ADSL and you want to provide age. So you can write ADSL like this in the next line, ADSL dollar symbol and age. By this you can provide in this, so it will extract that age variable and pass the value to the function, and then check whether the wherever the missing age is there, it will give you the missing, and wherever age values is present, it will give you the not missing. So by this function, you can easily do the QC or for the clinical data for missing values. So this was the function which is very important for the clinical domain. Okay, now coming to the data set as a input. Function taking data set as a input. Previously, we were doing like we are passing the values, we are passing the vectors, or these kind of stuff we were doing. But now we want to take value from a data set. How we can do? Let's explore. Let's create one data set for this. Adam, Adam underscore. Oops, where I'm going, I don't know. Yeah. Adam underscore data, and I'm creating data frame, data dot frame. I'm using table also you can use from Tidyverse. So for now, I'm using the data frame function, and I'm creating use subg ID. In that use subg ID combined operator, I'm using its caps lock again. Let's say I'm giving 01 hyphen 001. Okay. Second, I am giving 02 hyphen 002, 0, 01 hyphen 003. This is study. This is our 01 study, and this is our subject ID. So by this done, the subject ID we created. Now create the age. Combined operator, and for age, let's say any number 56, 78, 45. Done. Three subject, three age we gave. Just run this. This is our three observation we have and the two variable we have in this data set. Okay. Now we want to create one function on this data frame. So flag, let's go for the age underscore flag. function argument. I want to give data, which data I want to use, and age underscore var, age variable I want to give curly braces, and then I'm creating one new variable in the same data. In this data, which I am using as an argument, I am creating one data. How we can create data dollar symbol, and let's say I'm creating age flag after this variable I'm creating in the same data. If else data, this is data. If else this data, I'm subsetting. Now I'm subsetting this variable. How? We subset age underscore var in function. By this we subset our data in a function with using two square bracket. This is very important. Now 65, I'm using this age. I'm saying if this is true, say yes, else say no. Fine. Okay. This is a function I created. Now just okay, we can print the data as well. Just print the data. Okay, done. Now call our function. This is our function. I'm calling this. Which one is our data? We have to provide two arguments, data and variable. Okay, data is this. Which variable I want to create? Age. It should be in quotation. Just run this. Look, I created one new variable, that is age apple. In that, age is 56. No, because it is less than 65. We ask greater than and equal to. That's why two no's and one yes. So by this we can create function for filtering our data or for creation of new variable flag in the existing um, data set. So this is the way. Basically, this is very important concept in clinical. We create a lot of functions for table creation, for summary statistics. So we use these kind of things definitely for creation of that functions. Because let's say you are creating a demographic tables, in that you are calculating statistics for age, height, and weight, BMIs. So for that you create a one function. In that you will use this kind of stuff very commonly. So so basically, why we use this double square bracket and why we use quotation mark for passing the value. This is a completely different concept. For now, you can understand that we are passing a string in uh, while calling the function, and this is for dynamic function creation. This is called as a dynamic function creation. This is better way. But if you don't want to use this double square bracket, how we can do with the single square bracket? By just subsetting our data. How we can do? You can do the same thing with this. Let's say just copy paste and here. Instead of using this, what you can do? Just remove the double square bracket because we are used to of that, right? We want to subset all the rows. First is for rows. Like we want to subset all the rows, and we want to uh, use this variable for calculation, and just add drop is equal to true. Why we are using drop is equal to ensure that we are getting as a vector input to, we are passing a vector input to the function. This ensure that we are passing vector, not the data frame, right? So by this as well, you can get the same output. Yes, by this also. So this and this is equivalent. So you can use this and this, but this is more dynamic and safe. Safe, you can say. You have to write so many things here, but here just you have to just add the two double square bracket. You can create your function more dynamically better by using a Erlang package from Tidyverse. In that, you can use bang bang function to make your function more better and more automate. You can do more automation with that. So yeah, there are so many ways to create function. It's everyone's personal choice and personal requirement that what they want to create. So yeah, but for clinical domain, automation is very important. So function creation is very important part of right clinical domain. So it's very this example is very important to understand. Next is function returning multiple value. Let's take one more clinical example for this. Let's say I want to calculate the age summary. Age, which we usually create for table creation, statistics for age tag. I'm giving this name, function, and creating. I'm passing one argument, age vector. Okay, what we can do. Let's say we want multiple output. As I already explained, if you want multiple output, you have to use these two way, list and this vector. So I'm using list as for getting the multiple output. List, I want minimum age I want. For that I'm using min function and I'm passing this vector. And I don't want any missing value to create any problem in my calculation. So I'm just saying na.rm is equal to true. Just copy paste this function and let's say I want to calculate max, I want to calculate mean. Just change the names. I want max, I want mean. Done. Function also you have to change. Max I want and mean I want. Everything else is same. Just run this function. Okay. We have to give commas because we are creating a list. We have to give something to separate. Now I'm calling this function and I'm giving this vector as a output. From this, control C and dollar symbol and which variable? Age. Because statistic we are calculating, we have only one numeric variable in our data frame in Adam underscore data. Just run. Okay, there is some. Okay, we have to first run the function again. Now see, look, minimum age 45, maximum age 78, and the mean age is this. So by this you can get the uh, multiple output. Let's say you want to see in a vector form. Just add C here and run the function and in a vector form you can get. So that two method are very important if you want to get the multiple output from your function. So you can use these two method, combine operator and the list. And in the if you have to pass the vector, you can pass like this in vector output to your function. So by this you can calculate the multiple sub statistic for let's say you have two more numeric variable. Let's say age, height, weight. Just change this weight. It will calculate the weight, some statistics for weight variable. So by this is very versatile. This is very good for automation, just like macros in SAS. So it's similar thing. So next function is function with validation check. Very important for QC. How we can do. This is the last function for this tutorial. So let's create one function, validate underscore age function, and I'm just passing one positional argument here, and I'm saying if condition age is less than 0, then stop. Stop the stop executing the statements. So you can stop execution, you can stop, and then age, you can give one message as well. Age can't be negative. Just give this message whenever this condition is true. Okay. Now, otherwise, just print the age. Okay. This function I created for validation. Let's say I'm giving. You can pass the vector as well, but for now I'm just giving one argument. Values like this. Let's say I'm giving the age value is 30. Just run. Okay. It's showing this because it is greater than 0. Now let's say I'm giving value -5. Just see, it's showing error. Age can't be negative. It stopped here. It stopped execution here and showing me the error that I gave. Whatever error you are giving, whatever text you are giving, it will show you here that this execution is stopped because age can't be negative. Passing these kind of messages in our code, we can do validation checks for our code. So that's it for our deep dive into functions in R. So today we learned how to create custom function with or without arguments, how to return single or a multiple value using the return or a list, how to handle variable numbers of argument with dot dot dot, ellipses with ellipses, how to check missing value and create flags, how to dynamically select column in a function using double square brackets, and with drop is equal to true method. The difference between logical and the global variable we learned inside the function by using the two greater symbol. We can create the global variable. So basically, functions are a building block of clean, reusable, and efficient R code, especially in clinical programming. So my tip is practice creating small function every day if you are a beginner, even for a single task like flagging patients, summarizing lab values, or checking some missing data. So if you understand function well, it will save your time definitely, because without function we usually write the repetitive codes, right? So uh, with function we can save our lot of time. So functions are very important. So for now, thank you for watching. Don't forget to share, and subscribe if you like this video, if you found this video helpful. So I will see you in my next video. Uh, for now, bye bye.